Okay, so what you're looking at right now is just the rules for exponents that we've covered in class so far. X to the 0 equals 1. Any number to the 0 power equals 1. X to the negative 1 equals 1 over x, or conversely 1 over x to the negative 1 equals x to the first. So if the exponent is negative, change the position from either numerator to denominator or denominator to numerator. Multiplying numbers of the same base is number 3. X squared times x cubed equals x to the 2 plus 3, which of course is x to the fifth. Dividing numbers of the same base logically follows multiplying numbers of the same base. If you're dividing, you're going to subtract. So x to the 6th over x to the 4th equals x to the 6 minus 4, or x squared. And power to a power, x squared quantity raised to the 6th power is equal to x squared, or excuse me, x to the 2 times 6, or x to the 12th power. Okay, so question number 1. This is power to a power. This is page 207, number 1. I'm going to make one video for all of these exercises. And so if you scroll with your with the bar on the video and look for the number in the upper corner, you should be able to jump to questions that you want to if you don't want to watch the first 1 or 2 or 3 or whatever. So anyway, here we go. So z to the 5th all raised to the 3rd power. Okay, and so that's going to become z to the 5 times 3. Power to a power rule, right? And 5 times 3 is 8, and so that's going to equal, 5 times 3 is 15, so that's going to equal z to the 15th power. Okay, so pretty straightforward on the first one. Number 3 is going to be similar to that. I've got m to the 4th power, and that's all being raised to the 10th. Power to a power, multiply exponents, so it's m to the 40th power. Similar once again, I've got v to the 7th power, and that's being squared, and so that's v to the 14th power. Now we get a little bit more complex because I have the b on the outside. The negative 3 power does not apply to that b. So order of operations says parentheses, can't do anything on the inside exponent. So I'm going to apply the negative 3 exponent to the b. So I have the b on the outside, and then I have the b on the inside, which is being raised to the negative 8 power, and I'm multiplying that by negative 3. So it's being multiplied, not subtracted, right? So that then becomes b times b. Well, negative 8 times negative 3 is positive 24. Negative times a negative is positive 24. And this is really b to the first, right? If I don't have an exponent written, it's understood to be to the first. So that's b times b to the first, b to the first times b to the 24th. And so that's b to the 1 plus 24, or b to the 25th power. So that's a little more complicated, right? Because you got that b on the outside. But just follow the steps, follow the rules, and you're going to get it right. Number 9, similar to the previous one, the number 7, except that now the number on the outside is a different base. And so I've got m squared to the 7th power, so that's the power to a power rule, times n to the 5th. And so then 2 times 7 is 14, so I've got m to the 14th power times n to the 5th, or just, you could write it m to the 14 n to the 5th. You don't need to write that, put the dot in between. Nothing I can do with that, right? M and n are numbers that are different. It's a different base. You cannot add or do anything with those exponents. Number 11, again, we're getting more complex as we go. So now I've got g to the 5 times negative 5 times g, let's try that again, times g to the 6 times negative 2. Okay, and so 5 times negative 5 is g to the negative 25 times 6 times negative 2 is negative 12. Now I'm multiplying those two numbers. So originally it was power to a power, now I'm multiplying, and so that's going to be g, let's see, what's negative 25 minus 12? Plus negative 12 if you wish, but it's still the same thing. That's going to be negative 37. So there's the last one. There you go.